Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list. We have learned about basic operations and we have solved few questions from this pattern. Now we are going to learn about new pattern called fast and slow pointer, which we massively use in linked list type of questions. So we have learned about all these pattern in the very first lecture of linked list playlist. I will attach the link somewhere here, you can definitely check it out. Now from this pattern, today we'll solve the very first question, which is middle of the linked list. So let's read the problem statement. The question says we'll be given the linked list and we have to return the node which actually exists at the exactly mid location. Means for the odd length, so definitely we know there is only one mid, but for even length we have two mid, and the question expects you to return the second mid. Means in this example number 2, 3 and 4 both are mids, but instead of returning 3, the question asks you to return the 4 but as node, not as value. So as node, when you return 4, so 4, 5, 6 whole will get returned. Okay, so let's see the constraint. The constraint says number of nodes will be 1 to 100. It's very small, so we need not to worry about the overflow and so on. And most important thing, in linked list we rarely solve questions using n square time complexity, but we mostly do in linear solution itself. Okay, so definitely I have this length, and if it is even or odd, suppose it is not linked list, so definitely if we have length, so with the length divide by 2 we can go and we can return it, but this is linked list, we cannot do that. So how can we do? The very first approach is start your current pointer, keep on running, like moving your current pointer ahead until the current hits null, and calculate the length. Now once the length calculated, let's say 5, correct? So 5 divided by 2 means 2.5. Can I say 2? So means if we want this, we want 2 jumps. So total length is 5. Once calculated, you will again restart your current pointer and take exactly total length divided by 2 jumps. Okay, so when you will do 2 jumps, 1 jump, 2 jumps, so you will be here, and this node you have to return. Very simple. But what is the time complexity? The time complexity will be O of n you have used to calculate the length, and then further O of n by 2. Although O of n plus n by 2, which is 3n by 2, is linear only, but in linked list n plus solutions are mostly brute force, and when you can write this in O of n or O of n by 2, you can say you have written the optimized code. So for odd, so we are clear, but what about even? For even, let's say we don't have this 5, that's it, we have. So total length is 4, we have to return this. So when can we reach? Like by taking how many jumps? 2 jumps. So hence total length divide by 2. So 4 divided by 2. So here also we'll follow the same total length divide by 2 rule to take that many jumps to return the node. Very easy. And I hope you can do that. Now let me show you the same code for this. Okay, so here is the code. First we will initialize a length variable, and then we'll start a current alias from the same head point, because in linked list we don't touch head, but we make a different variable or alias which help us to calculate the answer. Okay, so we'll rename, so we'll make a current pointer, and while current is not null, we'll keep on moving our current ahead and calculating the length. Once the length calculated, the middle will be length by divided by 2, and again we'll restart our current from the same head, and now we will run the for loop or while loop for middle length, and whatever the current comes, that current will be our mid node that we already show. Total time complexity is O of n to calculate the length and O of n by 2 for this middle one. Total O of 3n by 2. Still linear, but this is not the optimized code. Let's run the code and let's submit this code for you. Definitely it will show that it is faster solution because the constraint is very small and it's anyhow linear. Now let's see how can we write the optimized code. And for that I would like to take 2 examples. One is for even and one is for odd. Okay, so let's say we have 5 here also and null. That's it. Okay, so the second approach which help us to get the mid element in just one iteration is slow and fast pointer. And what does that mean? It means slow will always move one step and fast will always move 2 steps. The reason is after every iteration you will find fast is always 2x distance, or you can say slow is always half of the distance of whatever fast has covered. So fast and slow pointer, we start from the same head, and in the next iteration slow moves 1 jump and fast moves to 2 jump. Means till here you know midpoint is 2 and that's where slow is pointing to. Now in the next jump slow will move to 3 and fast will go to null. Correct? Now still as a fast has become null, so you can say what you have to return? Slow, which is 3. Okay. So in this case, when fast became null, you will return your answer. Now let's see in this case. Where is fast and slow initially? At head. Now we'll reinitialize our slow and fast in this case. Slow will take 1 jump, it will reach S, and fast will take 2 jumps, so it will reach 3. Now as of now, you know 2 is a mid, that's where slow is pointing to. Now the next iteration, slow will move 1 jump, means here, and fast will move to this, means here. So do you think we should move forward? Because slow is present exactly at the location what we want. So in this case, when we stopped? When our fast was null or fast dot next was null? Definitely fast dot next. So in case of odd length, when your fast dot next becomes null, you will stop. So both of these two conditions we have to mention in the while loop, and inside the while loop we have to move slow is equal to slow dot next by 1 jump and fast is equal to fast dot next, saying it's taking 2 jumps. So what we have to write? Definitely slow and fast we will initialize or start from the same head. Correct? Now in the while loop we have to write ki while my fast not is equal to null, because fast will become null first and then fast dot next. Okay. Also in between we have to add AND operator. Why? Because suppose in this case when my fast became null, so if you will use OR operator, so it will say fast is not null, so it will say no, it's false. So OR operator looks for the second statement also. What if it will become true? So it will go and check fast dot next not null. So it will say, hey, fast is already null. Null dot next will give you null pointer exception. So hence we cannot use OR operator here. Instead we will use AND. And now in the second condition we'll check while my fast dot next is also not null. Now inside this what we have to do? Simple. Move your slow by 1 step, means slow is equal to slow dot next, and move your fast by 2 steps, means fast is equal to fast dot next, and that's it. And after finishing this while loop, we know wherever our slow is pointing to, that will be our answer. So let's write the code for this. So here is the code I have written for you in Java, which we have discussed. Started our slow and fast pointer, taken the condition in the while loop and moved our slow and fast with different speeds. And after coming outside, we have to just return the slow. So let's run the code, and definitely it has been passed. So let's try to submit this code as well. Done. So this was a code in Java. The total time complexity is exactly O of n, not 3n by 2. Okay. And space is constant because we have not used any extra space. Instead, we just take 2 pointers. So this was the code in Java. Here is the code in C++ if you are from C++ background, and here is the code in Python if you are from Python background. So that's it. With this hope that you understood the fast and slow pointer concept, and this question will go and mark the very first question in the sheet. I hope you will do on your own, and if you have understood, please do let me know in the comment section, and also subscribe the channel and like the video if you have not yet. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.